James Webb Telescope has shared a new image of Uranus.
So Neptune's interesting. The weather is changing on Neptune.
We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system.
Have you ever wondered what lies beneath the serene blue exteriors of the ice giants in our solar system, Uranus and Neptune? These distant worlds, often overshadowed by their more famous planetary siblings like Jupiter and Saturn, hold a treasure trove of mysteries. They might seem plain and uninteresting at first, but underneath their surface, there's a jaw-dropping surprise waiting for you, a never-ending rain of diamonds. And believe us, that's just the beginning of the incredible stories we're going to share with you. Imagine a place where the temperatures plummet to a mind-numbing minus 224 degrees Celsius, minus 371 degrees Fahrenheit. That's right. Uranus is a frosty wonderland. Its atmosphere is an intricate mix of hydrogen and helium, with a splash of ices like water and ammonia. The lower clouds are crafted from water, while the uppermost layer is of methane. This ice giant does a celestial backflip with a marked axial tilt of 97.8 degrees, coupled with a retrograde rotation rate. In other words, while we enjoy our typical day and night, Uranus experiences a mind-boggling 42 years of continuous sunlight at its poles, followed by 42 years of eternal darkness. Talk about a never-ending day. Size does matter in the world of planets, and Uranus doesn't disappoint. It boasts the third largest diameter and the fourth largest mass among its planetary peers. Underneath its volatile mantle layer lies a rocky core, surrounded by a thick hydrogen and helium atmosphere. Uranus harbors some enigmatic climate phenomena. Winds that whip at an astonishing 900 kilometers per hour. That's 560 miles per hour. Variations in its polar cap, and clouds that defy explanation. Why? Well, that's a question that keeps scientists scratching their heads. Uranus is also a heatless wonder among giant planets. It doesn't quite follow the heat is a given rule that its planetary siblings abide by. The reason behind its icy demeanor remains a riddle yet to be unraveled. Now let's talk about cosmic bling. Yes, Uranus has rings too, but don't expect dazzling sparklers. Its ring system is the shy type, reflecting only a mere 2% of incoming light. And it's not alone. It hosts 13 inner moons in its orbit. 5 major moons orbits Uranus. Meet Miranda, Ariel, Umbriel, Oberon, and Titania, celestial beauties that circle around their icy giant companion. As if that's not enough, Uranus has a quirky family of 9 irregular moons that choose to keep their distance. They're like the rebels of the Moon Clan, and their presence adds to the intrigue of this distant world. Uranus is also quite the magnetospheric puzzle. Its magnetosphere is highly asymmetric, teeming with charged particles that may hold the secret to why its rings and moons are so dark. Now let's rewind the celestial clock. Uranus was lurking in plain sight but went unnoticed until 1781, when the brilliant William Herschel first spotted it. Imagine that, a planet hiding in our cosmic backyard. It wasn't until later that Uranus got its name from the Greek god Uranus, one of the primordial deities. Fast forward to 1986, when the Jupiter 2 probe made a close encounter with Uranus. It was our one and only up-close date with this icy giant. And guess what? We want more. The Planetary Science Decadal Survey has its sights set on a proposed Uranus orbiter and probe mission, making it a top priority in the 2023 to 2032 survey. Now, let's talk about Neptune. This distant 8th planet in our solar system is truly a celestial enigma. It's the 4th largest planet by diameter, the 3rd heaviest, and the densest among the giant planets. Imagine a world that's a whopping 17 times more massive than Earth. Neptune stands just slightly taller than its cosmic twin Uranus, but it's denser and physically smaller due to its colossal mass, which causes gravitational compression of its atmosphere. Now, here's a fascinating fact for you. Neptune doesn't boast a well-defined solid surface. It's composed primarily of gases and liquids. Picture a massive ocean of swirling gas and liquid elements, making it unlike any place you've ever seen. One of the most intriguing aspects of Neptune is that it's not a planet that can be easily spotted with the naked eye. In fact, it's the only planet in our solar system that was discovered through mathematical predictions rather than direct observation. The story goes like this. Some unusual deviations in Uranus's orbit raised suspicions that an unknown planet was at play, tugging at Uranus with its gravitational force. After the brilliant Alexis Bouvard proposed this hypothesis, the position of Neptune was predicted independently by two extraordinary minds, John Couch Adams and Urbain Le Verrier. It wasn't until September 23, 1846, that Neptune finally made its debut through a telescope, courtesy of Johann Galle, who spotted it just a degree away from Le Verrier's prediction. Shortly after Neptune's grand entrance, another captivating discovery awaited us: Triton, Neptune's largest moon. However, it wasn't until much later, during the 20th century, that we managed to locate the other 14 moons of this distant giant. Neptune's considerable distance from Earth makes it a real challenge to study with our trusty Earth-based telescopes. But in 1989, Voyager 2 swooped by Neptune, providing us with invaluable insights. As of now, it remains the only spacecraft to have ventured so close to this distant neighbor, and in recent years, thanks to the Hubble Space Telescope and ground-based telescopes equipped with adaptive optics, we've been able to observe Neptune in even greater detail. Alright, let's get to the nitty-gritty of Neptune's composition. Just like its gas giant companions, Jupiter and Saturn, Neptune's atmosphere is primarily made up of hydrogen and helium. But here's where things get fascinating. It's also enriched with traces of hydrocarbons and possibly nitrogen. Yet the real kicker is the abundance of ice like water, ammonia, and methane. Speaking of methane, it's responsible for Neptune's captivating blue appearance, along with a little something called Rayleigh scattering. But recent data from the Gemini Observatory reveals that Neptune's blue hue is even more vivid than Uranus, thanks to its thinner atmospheric haze and heightened activity. Now let's talk about Neptune's weather, shall we? Unlike its hazy sibling Uranus, Neptune boasts a lively and ever-changing atmosphere. Back in 1989, during the Voyager 2 flyby, the southern hemisphere of Neptune showcased a massive feature known as the Great Dark Spot, reminiscent of Jupiter's Great Red Spot. And in 2018, scientists identified a newer main dark spot along with smaller ones. And here's a fun fact. Neptune boasts the most powerful sustained winds in our entire solar system, with recorded speeds that could leave even the fastest race car in the dust. We're talking about wind speeds reaching a staggering 2,100 kilometers per hour. With Neptune's colossal distance from the Sun, it's no surprise that its outer atmosphere is one of the iciest places in our solar system. Temperatures at its cloud tops plummet to a chilly 55 Kelvin. But things heat up quickly as you journey towards Neptune's core, where temperatures soar to a scorching 5,400 Kelvin. Finally, let's not forget Neptune's delicate ring system, often labeled as arcs. These ethereal rings were first spotted in 1984 and later confirmed by Voyager 2. While they may not be as grandiose as Saturn's dazzling rings, Neptune's arcs add a touch of cosmic elegance to this distant ice giant. Now, let's talk about something fascinating: the phenomenon of diamond rain on Uranus and Neptune. The idea of diamond rain isn't as far-fetched as it may sound. It was actually proposed even before the Voyager 2 mission, which was launched back in 1977. Here's the basic idea. We know what makes up Uranus and Neptune, and we understand that as you go deeper inside a planet, things get hotter and denser. Scientists have used mathematical models to delve into the specifics. We know that the innermost regions of these planets' mantles have incredibly high temperatures and pressures that are a whopping 6 million times greater than what we experience on Earth. So, what happens to substances like water, ammonia, and methane under these extraordinary conditions? Methane in particular faces intense pressures that can actually break it apart, releasing carbon atoms. These carbon atoms then come together to form long chains. When these long chains huddle together, they arrange themselves into crystalline structures that resemble diamonds. These dense diamond formations then slowly descend through the layers of the planet's mantle until they reach a point where it becomes too hot. At that temperature, they vaporize and start floating back up to repeat the cycle, which is why we call it diamond rain. So yes, there really is diamond rain on Uranus and Neptune. So do you know any interesting facts about these ice giants? Share your thoughts and theories in the comments below. And don't forget to subscribe for more mind-blowing space explorations.